Good morning, students. We'll start with the today's class. Okay. We'll start with the today's class. In the previous class, we started with module 3, and we have discussed briefly about what is the concept of fan in, fan out, and how a two-level or a multi-level circuit has to be designed. And we closed the discussion with one example wherein one SOP expression was given, and it was asked to draw the logic circuit for that same using like 2-level and 3-level circuits. I hope all of you understood that particular example. And at the same time, I have given you one homework also, the same example which we have solved. I hope it is visible on the board, that same example which we have solved in the last class. Is the board visible?
Yes, sir.
Yeah. So already we have implemented this equation in SOP form with 2-level and 3-level implementation. And I have asked you to implement the same, like you have to solve the same example using what? It was asked to solve the example to get the 2-level and 3-level OR and combinational circuit. Now, how do we go about this? Anybody has tried this example? Anybody has done this homework? I have told you to implement it using OR and logic. I have done it for AND OR. That is, SOP will be always in AND OR form, and POS will be in OR and AND form. Anybody has tried OR and implementation of the same expression? Yes? Or say at least yes or no. You will not be punished if you say no. If you have done it, say yes. If you have not done, say no. If you have tried but didn't get, you can tell, sir, I tried but I stuck it here in this particular step. Yes? Anybody has tried it? Anybody has tried solving this particular example? Say at least yes or no. So I am getting only one no from Adnan. Now what about others? Yes. That's what, always there is a starting problem. If someone starts, then everybody will see. Now I can see so many no's, but nobody will start first. Right? Everybody will look at each other in the regular class also, and here also the same thing. Right? That's the reason why I'll take up this example further, and we'll see how we can do the implementation of this particular sorry for the interruption. Right. So now how do you go about this further? Right. So there are two ways. Like they ask you to solve this above example and implement it. So what you can do is you can draw like one more K-map, right? And then group zeros and write the expression directly in terms of POS. But what I've done is already I have written the expression which is in SOP form, and the KMAP also is done for SOP. Now I want to use the same KMAP instead of redrawing the KMAP and then writing this term like A bar B bar can be written as A plus B, then A plus B bar and so on. What I do is I tell you one more method, alternate method, how you can get the POS expression from the same KMAP instead of changing it. Now what we need to do is here I have formed the groups of ones. We will form groups of zeros now. So you form one group of zeros here. There is another group of zeros, right? Then maybe here you can form one pair of these two zeros, another pair of these two zeros, right? So what I did is I have formed the group of zeros now, right? After forming the group of zeros, I will be writing the expression. This was the expression for SOP. This we already implemented. So I will clean this now. Now we'll see how do we write the expression for POS. Now I am writing the POS expression using the SOP KMAP. So when you do that, whatever the grouping you have got, you write what is the corresponding product term for that. Can you tell me what is the product term for this group? If you consider this group of zeros, what is the product term corresponding to that? Yes?
CD.
What is the product term corresponding to the first group of zeros?
C plus D.
What is that?
C plus D. C plus D.
No, what is it? As it is, you have to write. That's what I am telling. Don't get confused with the SOP and POS. I am telling a different method now. All of you carefully listen to this. Now, whatever the group you have formed, it is C bar D bar. So you write C bar D bar plus. What for this you will get? This one group of zeros you have formed.
CD.
What will you get?
CD.
CD.
CD. Right. Then for this group, it is A, B bar and C bar, and then it is A bar, B bar and C, right? Then you may ask for one also we have written group of ones also we have written same, and group of zeros also we have written the same. If you are using this particular technique to simplify the given equation and to get the POS expression in the same KMAP, just form groups of zeros, and after forming the groups of zeros, write whatever the group we have formed, write the corresponding product term. But since here instead of grouping ones you have grouped zero, this should be written as F bar instead of F. That is the important change that we should. So if you club ones and write the equation that is SOP equation, you will get F. And in the same KMAP, if you club zeros and write the SOP equation only, what you are going to get is F bar. I hope it is clear. Any doubts here? All of you getting this?
Yes, sir.
If you form a group of zeros, you will get F bar, and if you form a group of ones, you will get F. Is that clear? The difference between the F bar and the F expressions, what we will be getting from the same KMAP. If you use the same KMAP, right? If you club ones, you will get what is called as SOP equation. And if you club zeros, still you are getting SOP equation, but you are getting complement of that particular function. But I am not interested in complement of function. I want this function F only. So what you do is F bar equal to this. So if you want to get F from this becomes C bar D bar plus CD plus A B bar C bar plus A bar B bar C, its complement. Is that clear? F bar equal to this. So what is F? You have to take complement of this. If you take complement of both things, you will get F. And now easily you can write what is the complement of this. For that, you should know what is called as De Morgan's theorem. Can anybody state what is De Morgan's theorem? it used De Morgan's theorem. Now easily you can write the simplified form of this. So what is De Morgan's theorem? How do you write? By using De Morgan's theorem, right? So De Morgan's theorem says that what? A dot B whole bar is equal to A bar plus B bar, and A plus B whole bar is equal to A bar dot B bar. Complement of logical sum is product of individual complements, or complement of logical product is sum of individual complements. That is what is the De Morgan's theorem, and it plays a very important role here. So when you use De Morgan's theorem, now here you have plus, plus, plus. So this plus will become dot, and you will get the individual complements. So you will get this as C bar, B bar, its bar, dot CD bar, dot A, B bar, C bar, its bar, dot A bar, B bar, C, its bar. Whole bar you are splitting into individual by replacing plus to dot. Is that clear? And then finally you can write this expression here as C. Again you have to use De Morgan's theorem here. C double bar plus D double bar is nothing but C dot D. Here C bar dot D bar. Here A bar plus B plus C. Here A plus B plus C bar. This is the final equation, and it is in which form? The final equation, what you have got is in which form? Yes?
POS.
This is in POS form. I have not done any changes in the K-map. Same K-map I have used. I have clubbed zeros here, so I started with F bar, and then I obtained F from this F bar by using De Morgan's theorem, and finally we come to expression which is called as POS expression. I hope the POS expression what you have done is clear. Is this clear?
Yes, sir.
Yeah. What is the next step now? Actually, they ask you to solve the above example and get 2 level and 3 level OR AND circuit. Now, can you get the OR AND circuit for this? How do you get all these OR terms? That is product sum terms you will get using OR gate. Product terms you will get using AND gate. So you can get one by one. C plus D is required. So I can have here one OR gate. I give C and D. Another OR gate, I will give C bar and D bar. Another OR gate, wherein I will give this as A bar, B, C. The fourth OR gate, wherein I will give the input as A, B, C bar. And finally, these four, you should give it to what? One? Yes? 4 input AND gate, and this circuit is called as what? What is this circuit is called as? It is 2 level. Yes, 2 level. What circuit it is? This circuit is called as 2 level what? OR
AND gate.
circuit. 2 level OR AND circuit. Is that clear? All of you understood this? And say yes or no. The simplification part also you understood, and you got the circuit diagram also.
Yes, sir.
Is it clear?
Yes, sir.
Any doubts here?
No, sir.
If you don't have any doubts, quickly take down that. We'll see now how to get the 3 level. Right? How we can get the 3 level now from this 2 level. Once you have 2 level expression, it can be easily converted to get the 3 level circuit. Right? The next part we are going to see that. Before that, if you are not completed, just complete it fast. Yes. The next part is to get the 3 level OR AND circuit. So how do you get 3 level OR AND circuit? Chandan, can you explain me? This expression we have, now from this we have to get a modified expression so that we can have a 3 level circuit drawn. What do we do to get the 3 level circuit? Yes?
So you need to factorize, but I don't know how.
Yes, how to do that factorization? That is what is important now. Right? Once you do the factorization, easily you can implement this. Right? So when you are implementing like a 3-level OR AND circuit, when you go for 3-level OR AND circuit, you have to see that the AND, now if you see here the AND gate, it requires how many inputs? In the 2-level OR AND circuit, the AND gate, what you have used, the fan-in of that circuit should be minimum how much? Yes? What is the fan-in of this particular circuit? Yes? Yes? You can see there that AND gate, what you have used is having 4 inputs. So the fan-in of that particular gate is 4. But sometimes they may ask you to implement it using only 2 input gate or 3 input gate. In that case, you can't draw that particular circuit. So that's where you have to go for factorization. Now, how do we factorize this particular expression? I have the expression C plus D, right? Then C bar plus B bar, A bar plus B plus C, A plus B plus C bar. This expression you need to factorize, and once you factorize that, then you can draw a 3-level circuit. So we'll see how to draw that 3-level circuit for this particular expression, right? So you need to do the factorization. So how we can do the factorization now? Yes? How we can do the factorization of this? Can anybody explain me how we should do the factorization of this? C plus D, right? And then C bar plus B bar and A bar plus B plus C, A plus B plus C bar. How we can do the factorization of this? Ultimately, you have to get this particular term by factorizing the same. So what I do is, I will write this equation, say C plus D I will write, right? C plus D, one term is there, that I will multiply with, say, first term, that is 3 term A bar plus B plus C. And then I write C bar plus B bar into A plus B plus C bar. Alright? A plus B plus C bar. Right? So if you observe this, this is of the form C plus D into C plus A bar plus B, I can say. And this is C bar plus D bar into C bar plus A plus B. Is that clear? C plus D into C plus D plus A bar and C bar plus B bar into C bar plus A bar, because here C is there, here C is there, here C bar is there, here C bar is there. So I have clubbed those two. And now once you club those two, this I can write it as, I will write C is here also. So I write that C plus this D into C plus D into A bar plus B. This is first term, C plus D into A bar plus B. This into, here I will write it as C bar plus D bar into A plus B. Right? I don't know how many of you understood this. How this has to be, the simplification has to be done here. You can see. Now, if you simplify this again, you should get this. What I get is C is as it is I have get, then A bar D, right, plus BD, you will get. Whereas when you simplify this to C plus D into C plus A bar plus B plus C, what you are going to get? A bar C, right? Then C plus A bar C, then BC, CC, A bar B, BD, and CD. Right. So that is written as C plus D into A bar plus D, because here we have C plus D, Here we have C plus A bar plus B. So that property we have used C plus D into C plus I'll write that instead of C plus D. You can say like this: X plus Y into X plus Z. Can anybody tell me what is the simplification you are going to get that? What is the Boolean identity or property you have? If you come across the term X plus Y into X plus Z, what can be written as? That is what I have written here. What is X plus Y into X plus Z? Yes?
X plus YZ.
X plus YZ, very good. This is X plus YZ. How you can simplify and check? X into X is X plus XZ plus Y X plus YZ. So you take again the simplification, it comes out to this is one of the property of Boolean algebra. X plus Y into X plus Z is X plus YZ. The same thing I have used here. What is X here? C. So X plus Y, that is C plus D, and here it is C plus this. So this is your Z, this is Y, and C is X. C is X, this is Y, this is Z. So what I write? C plus Y into Z. So C plus D into A bar plus B. I have not done any change here, just I have used one Boolean property and I have written this. I hope it is clear. Chandan, is that clear now? How we should do the factorization? So to do the factorization, you should know all the laws of Boolean algebra, Boolean identities and all. Now once this is done, this I can write it as further C plus A bar B plus BD, right? This is one term. Then this into C bar plus A D bar plus B D bar. That is the second step. So this whatever the POS equation we have got, the system we have put it in different form so that using this modified factorized expression, now easily we can draw the logic diagram, and this logic diagram will be 3-level logic diagram. Why? You can see here we have 3 terms here also 3 terms we are having, and this OR operation can be obtained, and then the AND operation can be obtained using the same. So how do we get this? Right. So you can see here C plus A bar D plus BD I want. So what I can do is I will use one OR gate. Right. So here I will give that C, and then space is required. So I draw here one OR gate. For this I will give C, and then 2 more terms. Those are obtained from AND gate, another AND gate, right? And here the inputs for these 2 AND gates are A bar D, BD, right? Similarly, I will have one more gate here, that is C bar, and then I need 2 more AND gates with A B bar and B D bar. And these 2 what we have got can be given to the AND gate, and you will get the F. You can see this is 1 level, 2nd level, 3rd level. This is how we get the 3-level logic circuit for the given SOP equation. For the given SOP equation. Is that clear? Again, just a little bit manipulation you have to do using laws of Boolean algebra or Boolean identities, and then you can easily get the logic circuit, whatever level a circuit you want, 3 level, 4 level, 5 level, etc. Any doubts here? All of you understood? Yes? Any doubts? Is that clear? Right? So you need to practice, then only you will be perfect with these kind of examples. It is not that easy and it is not difficult too. Fine? Shall we move ahead? We'll go to the next example now. Yes? Good. Okay, it's fine. We'll go to the next example. You can take down this next example. All of you can take down this example. Is this example visible? Yes? Can you able to see the example on the board? Sorry, on the screen?
Yes, sir.
Yeah. What is that? Can you read, Sohan?
Realize f of a comma b comma c comma d equal to summation of 0 comma 3 comma 4 comma 5 comma 8 comma 9 comma 10 comma 14 comma 15 using 3 input NOR gates.
Only. Yes. So first take down that example, all of you. Then we'll see how it should be implemented using only 3 input NOR gates. Right. They are not asked directly to implement it as it is. They ask you to implement it yes. Yes, go ahead. Can anybody simplify that? How to do this simplification? Anybody done the simplification? Simplification is easy. Just simple K-map you need to solve. Right? And it is SOP equation. Right? Summation 0, 3, 4, 5, 8, 9, 10, 14, 15. From the groups of, right? But one thing you should remember, right? Though it is a SOP equation, but they ask us to implement it using what gates? Yes. So before you proceed further, one important thing you need to remember here, it is a SOP equation, but they ask us to implement using NOR logic, NOR gates. So what you should do, when you want to implement anything using NOR, compulsory you should have POS expression. And when you want to implement anything using NAND gate, you should have which expression? SOP. So for this case, now you draw the normal K-map, but club what? What you should combine? Yes, Omkar, what you should combine? Omkar, are you there?
Sir, zeros.
Yes. Right. SOP equation is there, but you need to form a group of zeros. So you form the group of zeros and check what you will get. Anybody has done it? Yes, you got the answer? Kiran? Yes, Kiran, you got the answer?
Yes, sir.
What is the answer?
I'm doing, sir.
Still doing. Do it fast. All of you do it fast. Form a groups of zeros. Right? Don't change the K-map. Use SOP K-map, but form the groups of zeros. So whenever you use SOP K-map and you are forming the group of zeros, instead of getting F directly, you will be getting what? F bar. That is the only thing you have to remember. Same procedure of SOP K-map simplification should be used, but instead of clubbing ones, you need to club zeros. And since you are clubbing zeros, instead of getting the function F, you are going to get complement of that function, that is F bar. You can write down this somewhere. This is very important. Yes, anybody got the answer for this then? Yes, Richa.
Yes, sir.
What is the answer you got?
Sir, still didn't solve.
Why
Solving, sir.
so much time?
Solving.
A simple came up, you need to solve. It's a matter of just 2 to 3 minutes.
Yes,
Anybody
sir.
solved it? Anybody got the answer? Sejal?
No, sir, I'm still solving.
Till solving. Aniket,
Yes, sir.
got the answer?
Yes, sir.
Yes, very good.
Sir,
Can
I
you tell
got
me the
F bar.
answer?
Only F bar I got to solve.
Only?
So I got F bar.
F bar only. That's what. First you tell me F bar. Then we'll see how to get F from that.
Yes,
I
sir.
am asking, give me what is the answer you got for F bar only first. Because directly you will not get F. When you use SOP K-map, clubbing with zeros, you are going to get F bar only. That's what I was telling. First tell me the answer for F bar. Then we'll see how to get F again. I'll tell you simple technique. In fact, you need not write all the steps of De Morgan's theorem. Directly, just in single step, you can write the F from F bar. That's a method I'm going to explain now. What is F bar you got?
So A bar C D bar plus A bar B C plus A B C bar plus A B bar C D.
So total 4 terms you got.
Yes.
Anybody got the same answer or different answer? Yes? Anybody with a different answer?
So five terms I got. Sir.
5 terms you got. Very good. Yes? Anybody
Yes,
with
sir.
6 or 7 terms?
So I missed one zero.
Yes,
So 5
Isha?
terms.
Isha, how many terms you got?
So 5 terms.
5 terms. Kedar? Kedar, are you there? Yes, Rehana?
Yes, I got 5 terms.
You got 5 terms. What are those 5 terms? I can just verify, check all of you whether you got the same 5 terms or not.
A bar, B bar, C bar, D.
All of you got the groups like this: 1, 2, 3 pairs and 2 isolated zeros. I hope all of you got the same. See, I had given the answer. Those who have not yet done, you can do it. Of course, the K-map is written in some different form, right? But the final answer will be same. You don't bother about that, because instead of writing AB first, AB, I have written it from this, but ultimately the cell number will change and the final answer will be different. The technique used here in this PDF is different. Just ignore that. Okay, what is the final answer you got? Just check whether you got the same answer. Yes?
Yes, sir.
Is this the answer you got? F equal to A bar plus B bar plus C, then A plus B bar plus C bar, then A plus C bar plus D, then A plus B plus C plus D bar, A bar plus B plus C bar plus D bar. The last 2 are the isolated ones. First 3 are the pairs. Is that clear? This is actually F bar, right? It is not F directly. You write it as F bar. Sorry, F bar only it is. Right. Or if you use direct SOP K-map, directly you will get this itself actually. Right. So now what is asked here is you have to implement it using only 3 input NOR gates. But if you want to implement this equation as it is, You can see this can be implemented using 3, 3, 3. Here 4 input required. Here 4 input required. And then since there are 5 terms, you need one 5 input gate. If you want to implement this as it is 2-level realization, if you do, you will get 3 input gates, 4 input gates, and one 5 input gate. Right? That's why you need to factorize it again. Right? So to do the factorization of this, what we have done is here we have written again the original expression in SOP form. Right? Because if you have in SOP form, factorization you can do easily. So the factorization is done again by taking complement of this equation, F bar equal to A B C bar. That is, if you use De Morgan's theorem, dot becomes plus, and you can see here A bar plus B bar plus C. If we apply De Morgan's theorem, it becomes A B C bar. That is what is written. That's what I told. Directly you can write. This dot can be changed to plus, and here A bar plus B bar plus C, what you are having, you can write it as complement of A bar should be taken as A, then B, and C bar. Similarly, this how you can write A bar B C. This how you can write A bar C D bar. This how you can write A bar B bar C bar D. And the last term you can write it as A B bar C D. A B bar C D. This is what is written here by taking the complement of this. So when you take the complement of this, right, we get this, and now you can just check. What you can do is here you can take A bar C common from both these terms. When you take A bar C common from this, it becomes A bar C into B plus D. And from this two, you can take B bar D common. You will get it as A bar C plus AC. So now how many terms we are having here? You can see this is one term, this is second term, 3 term. That means maximum 3 inputs are required here. In addition to that, individual term also you should check how many terms are here. Here OR operation of 2, this is one term. Then that is ANDed with C and A bar. So maximum 3 inputs we need here also. Here also we need maximum 3 inputs. Here 2 inputs ORed with these 2. You will get finally 1. And this 1 is ANDed with this and this. That means maximum 3 inputs only we need. You need not further simplify this or further factorize this. So directly you can take again the complement of this. Now you can see again how I have taken the complement. A, B, C bar. How it can be written as A bar, B bar, C. Then this plus should be changed to dot. Dot you are changing to plus. Now this plus should be changed to dot. This plus is changed to dot here. Then A bar C is there. This A bar C can be written as A plus C bar. Then this dot should be changed to plus, and this plus should be changed to dot. Whenever you are changing plus to dot or dot to plus, accordingly you have to take the complement of that variables, and finally we get this particular expression, right? And this expression now can be easily implemented using NOR gate, right? One by one you can see here. How do I get this? Like A bar plus B bar plus C, right? A bar plus B bar plus C, you give it to one NOR gate. Then this entire bracket term can be obtained using one NOR gate. But there are one like OR operation and one AND operation. So you take that. A and C bar directly you give because plus you want. To that you want B bar D. So you have to give here, you can see B and D bar. Right. Similarly, you get this. These two can be obtained from this gate and this gate. Then that is given to one more OR gate, and then that is ORed with B plus D bar. And finally, that is given to F. So this is how we can do the implementation. Like I know, like if you, this particular example deliberately I have taken, right? Wherein you think that there are a lot of adjustment has to be done and how to remember this. You need not remember anything, right? So this is how we can implement any given Boolean equation using limited fan-in gates. Here, what is the fan-in? They have mentioned 3 because they have asked us to use only 3 input NOR gate. So the fan-in given here is only 3. So we need to do all these adjustments, simplification, and then you can get the 3. You can see here any gate which you have used in this particular diagram is not having more than 3 inputs, because the fan-in limitation here is 3. Right? I hope all of you understood this. All of you understood that? I know many of you have not understood it. That's why I will not go for this particular method of realizing any given Boolean equation using limited fanning. For that, I'll give you a simple procedure, and with that simple procedure, you should be able to do it. But this example which I have done previously is an important example, right? You should be able to do it. Just go through that and you try it once again. Just take that example, do the grouping, do the simplification, factorization, and on your own, you try to draw the logic diagram, and then you try to compare your answer with the logic diagram given here, right? Because here directly, without using any shortcut method, we have implemented the given Boolean equation with 3 input NOR gates only, by changing the expression in such a way that every term can be implemented with only 3 inputs given to the NOR gate. Is that fine? As I said, you will go back to that example after I tell you one simple procedure for designing the circuit, minimum 2-level circuit, minimum 2-level NAND circuit, and NOR circuit, and then multi-level, and then you should go back to this. That is the reason why I have taken this particular example, right? So now I will give you a simple procedure. All of you can write it down. You write down this procedure for designing minimum 2-level NAND circuit. I am giving you first NAND. The same thing you can apply for NOR, and then we'll see what to do for multi-level circuit. I am giving for 2-level first, right? For time being, whatever that example I have explained, you just keep it aside. You have to go back to that example because that is very important example. Purposely, I have introduced that example in between. I know majority of you have not understood. I wanted to create the doubt in your mind, so I have given that example so that you should go back to that example and you should be able to understand, and you should be able to explain what exactly is done in that particular example. Okay, so now write down procedure for designing minimum 2-level NAND circuit. Right? Quickly just write down these 3 points, and then I'll give one simple example on this. You have to do this. Procedure for designing minimum 2-level NAND circuit. In that, you write the first point. First point in that, find the minimum SOP expression for given function. Find the minimum SOP expression for the given function. Is that clear? Then second point, draw the corresponding 2-level AND/OR circuit. Draw the corresponding 2-level AND/OR circuit. Draw the corresponding 2-level AND/OR circuit. Corresponding 2-level AND/OR circuit using, draw the corresponding 2-level, AND/OR circuit, full stop. Okay. Then write the third point. Third point, replace all gates. Replace all gates with NAND gates. Replace all gates with NAND gates, leaving the interconnections unchanged. Leaving the interconnection unchanged. leaving the interconnection unchanged. Full stop. If the output gate has any single literal as input, if the output gate has any single literal as input, complement these literals. Complement these literals. Complement these literals. Complement these literals. Okay. This whatever procedure I have given, it will be clear if you solve this particular example. So quickly, you can take down this example. Yeah, is the example visible there on the screen? Is it visible? Yes? Is it visible?
Yes, sir.
What is that? Read it. One of you should read and all other take down this example. Draw what?
Draw the two-level NAND
Draw the two-level NAND circuit for the expression f equal to sigma m 1, 3, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 1, 3, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Is that visible now? All of you have taken down that? A simple example, SOP equation. What is the first step? Here I have told, find the minimum SOP expression for the given function. How do you find the minimum SOP? This is the given function. Use the SOP K-map, club once and get the SOP equation. So all of you construct the K-map for this and tell me the answer. How many groups you can form and what is the answer you have got? Anybody got the answer? A simple K-map, SOP K-map now. Directly, no need to get any complement or anything like that.
Sir,
Directly you are going to get the SOP equation. Anybody got?
Sir, answer A plus B bar D plus BC, sir.
A plus
B bar D plus BC.
A plus
B bar D
D plus
BC. One
BC.
ox, sir, two pods.
Anybody has got any other answer? A plus BC plus B bar D. Hope all of you have got it. As he said, this is one what? What is this one? Octet. This is one octet. Then this is one. This is one what? Quad. And then the third quad is obtained by taking these two with these two. So the answer what you got is what? A plus BC plus B bar D. A plus BC plus B bar D. I hope same answer you got, Kiran.
Yes, sir. Same.
A plus BC plus B bar D.
Yes.
Okay, that is the second step. Draw the corresponding two-level AND OR circuit. What is the last step? Sorry, you have got the minimum equation. Now you have to go to the second step. Draw the two-level what? Corresponding AND OR circuit. Normal AND OR circuit, two-level. You can see here. A plus B and C and D. This is what you will get. This is corresponding two-level AND OR circuit. Right. Now, how it should be translated to NAND? What I have told in this procedure? replace all gates with the NAND gates, leaving the gate interconnection unchanged. That means interconnection you have to keep as it is, right? So this particular circuit you have to translate to NAND. So you don't bother how it should be done. Every gate should be changed to what? NAND gate. You do that. See here, NAND, NAND. All other things also you need to keep as it is. Everything is as it is, including input, interconnection. But there is one important thing that you have to remember. What is that? What is this point? Last point. If what? The output gate has any single literal. Now you can see here. Here, output gate here means what? This is called as output gate. AND gate is the output gate. Here it has single input, single literal. What is that single literal? A. So this has to be changed to what here? This has to be changed to what? Yes? Since the output gate has a single literal, in that case it should be complemented. Only the output gate. So here output gate is having this A. So instead of A you have to write A bar, and this is what is the logic diagram you are going to get for two-level NAND circuit. I hope the procedure what is given here you have understood with the help of this particular example, right? So procedure for two-level NOR circuit is same. You can see here. First, find the minimum POS expression for the given function. Draw the corresponding two-level OR AND circuit. Replace all gates with NOR gates, leaving the gate interconnections unchanged. And if the output gate has any single literal as input, complement that literal. That means like this. If you have a POS equation, draw the logic diagram. First having OR and then having AND gate, then convert each gate to NOR gate, and if any output gate has a single literal, it should be complemented, right? That is how you need to simplify and draw the logic circuits, right? I hope whatever is covered in this class, you people have got it. Just go through it once again. If you have any difficulties, you can get back to me. With this, we'll stop today's class.